Hello everyone, welcome back to my channel Smart Study with Mansi. This lecture session is all about the different types of dams. Before starting this session, I would like to explain dam first of all. Dam is that barrier which stops or restricts the flow of surface water or the ground streams. Reservoirs created by dams not only suppress floods but that also provides water for the activities such as irrigations, human consumptions, industrial use, aquaculture, navigation, and most often hydropower is used in the conjunction with the dams to generate electricity. Dam can also be used to collect or store the water which can be evenly distributed between the different locations. Dams generally serve the preliminary purpose of retaining waters and as well as while water other structures such as floodgates, dikes are used to manage the prevent water flow to specific land regions. Dams generally specified as the single purpose dam or the multi-purpose dams. As the dams generally classified as single purpose and multi-purpose, the main difference between the single purpose and multi-purpose dam is that the multi-purpose dams are constructed for the multiple uses for generating electricity, irrigation or navigation etc. But single purpose dams constructed for the particular use like it might be irrigation or it might be electricity. Again, the dam is classified as per the structure of the dams and the material used in the dam constructions, such as the arched gravity dams, embankment dams, masonry dams, and the different subtypes. A dam that is carved in the horizontal planes and usually built of the concrete, in which the horizontal thrust is taken by the abutments in the side of the valley, is known as arch dam. This arch dam must build on the solid rocks as a yielding material could cause the failure of the dams. Because of that, arch dam is designed so that the force of water such as hydrostatic pressures can resist the dam. As pressure against the arch causing the arch to straighten slightly, so it pushes into its foundations or the abutments of the dam. An arch dam is most suitable for the narrow gauge sections with the steep walls of the stable rocks to support the structures and the different stresses. Since they are thinner than the other types of dams, so it requires much less construction materials, making them economical and practical in the remote area of any country. Here, on the other hand, the multiple arch dam consists of a number of single arches dams with the concrete buttresses at the supporting of abutments. For the example, Denial Johnson's Dam in Canada is the best multiple arch dams in Canada. The multiple arch dams does not require many buttresses as the hollow gravity types, but it requires a good rock foundation because the buttresses loads are very heavy. Next dam in this category is the gravity dam. A gravity dam is a structure designed to withstand the loads by its own weight and by its resistance to sliding or overturning on its foundations. That is gravity dam. Newer dams of these types are typically composed of the unreinforced concretes or monoliths with the seals at the joints. But in the past centuries, the many gravity dams were constructed of the stone masonry usually. New masonry dams of the both gravity and arch designs are being built in India and China and in other lands also where the cost of the labor is low. So it is adopted overall vault to prevent the sliding and contract with the foundations, and the foundation itself must have the appreciable shear strength. In carrying the stability calculations for the many proposed sections of the dam, the uplift must be taken into account. Or here I want to explain what is uplift here. Uplift is the vertical force exerted by the seepage of water which passes below the dam, which penetrates the cracks in the body of the dams. Usually cracks develops because of this uplift pressures. So uplift pressures prevention is most important in the gravity dams. Next one is the arched gravity dam, which has the characteristics of both an arch dams and the gravity dams. The dam curves upstream in the narrowing shape that directs most of the water pressure against the rock walls and providing the force to compress the dam, which combines the strength of two common dams and it considered as the compromise between the two dams. Basically, this is made of the conventional concrete or the roller compacted concrete or the RCC masonry Arched gravity dams are not reinforced except at the spillways generally. A typical example of the conventional concrete dam is the Weir Dam. Next one is the Barrage Dam. Barrage Dam is the type of low head or the diversion dam which consists of a number of large gates that can be opened or closed to control the amount of water passing through it. And this usually allows the structure to regulate and stabilize the river's water elevation upstream for the use of in the irrigations or the other systems. The gates are set between the flanking fires which are responsible for the supporting the water loads of the pools created at the barrage. Barrage dams have a series of gates that controls the amount of water passing through it. A barrage dam can be used to divert the water for the irrigation needs or limits the water of the at the downstream sites of the water mains. The most cases the barrage dam is built near the mouth of the rivers generally. The sites of the dam construction needs to be thoroughly regulated or investigated to ensure that the foundation is strong enough to support the dams and it has the possibility of falling. So here next one is the embankment dam, which is primarily made of the earth or the rock fragments. Thus the term embankment encompasses with both the earth or the rock fill dams. These dams also referred as the dikes or simply embankments or the banks we can say. Next one is the rock fill dams or the embankments of rock fills, which is compacted free draining angular earth with an impervious zone. The earth used often contains a higher percentage of large particles, hence the term rock fill is given to this dam. The impervious zone may be on the upstream face made of masonry, concrete or plastic membrane, steel, pile sheets or timber or the other material we can say. So this is all about the rock fill dams. Next one is the earth fill dams. Earth fill dams we can say the earthen dams, rolled dams or the rolled earth dams or the simply earth dams are constructed as simple embankments of the well compacted earth or a homogeneous rolled earth dam is entirely constructed of the one type of material but may contains a drain layer to collect the seep water or can be effective in the regions where the cost of producing or bringing concrete is prohibited. Next dam is the fixed-crest dam, which is the concrete barrier across a river. Fixed-crest dams are designed to maintain depth in the channel for the navigation's purpose. They pose risks to the boaters who may travel over them or as they are hard to spot from the water, create induced currents that are difficult to escape there. This is all about the fixed-crest dam, which is for the navigation purpose only. There is a variability both the worldwide within the individual countries, such as in the United States, in how the dams of the different sizes are categorized. Dam sizes influences the constructions, repair, removal cost or the effects as the dams have, the potential ranges and the magnitude of the environment disturbances. So it is further divided into large dams or the small dam by its use difference. Large dams, the International Commissions on the Large Dams defines that a dam with a height of 15 meter or greater from the lowest foundation to the crest, or a dam between 5 meter and the 15 meter impounding more than 3 million cubic meter waters, or major dam over the 150 meter in the heights. The reports of the worldwide commissions on the dams also includes the large category dams which are between 5 to 15 meter high or with the reservoir capacity of the more than 3 million cubic meters are categorized as the large dam sections, where the small dams are the various multiple purposes, have the different multiple purposes, as the large dams or the small dams have the multiple uses such as hydropower productions, flood protections or the water storage. Small dams can be particularly useful on the farms to capture runoff or later used for the example during the dry season it is used for the storing the water. Small scale dams have the potential to generate benefits without displacing the peoples as well. The small or decentralized hydroelectric dams can add the rural developments in the developing countries also. So, Again, by the use, the dams are again classified as saddle dams, Weir, check dams, dry dams, divisionary dams, underground dams, tailing dams. So, saddle dam is an auxiliary dam constructed to confine the reservoir created by primary dam either to permit a higher water elevation and storage or to limit the extent of reservoir for the increased efficiency. Next is the Weir. Weir is a small dam that is often used in a river channel to create an impoundment of lake or to store the water for a minimum time or the water absorption purposes, which can also be used for the flow measurements or the retardations of the dams. Next is the check dam. Check dam is a very small dam designed to reduce the flow velocity and control the soil erosion at that particular dams. Or the conservatively we can say that the wing dam is a structure that can partly restricts a waterway or creating a faster channel that restricts the accumulations of sediments. Next one is the dry dam. A dry dam is also known as the flood retarding structure. It's designed to control the flooding. It normally holds back no water and allows the channel to flow freely except during the periods of the intense flow which the otherwise cause of flooding at the downstream sites. Or next one is the diversionary dam. A diversionary dam is designed to divert all or a portions of the flow of a river from its natural course. The water may be redirected into the canal or a tunnel for the irrigation or the hydroelectric power generations or the power productions. Next is the underground dam, which is the underground, and by names we can say that this dam is the underground or the store all or the most of its below surface for the extended use in the localized area. In some cases they are built to prevent the salt water for the inducing into the freshwater aquifers. Next one is the tailing dam. A tailing dam is typically on the earth-fill embankments dam used to store tailing which are produced during the mining operations after the separating the valuable fractions from the uneconomic fraction of an ore. Or conventionally, the water retention dams can serve this purpose due to the cost, and tailing dam is more valuable in that particular area. So friends, by material again dam is categorized as the steel dam, timber dam, and after that various other dams are like natural dams, coffer dams, beaver dams also there. So friends, this is all about the different type of dams. If you like my channel, please subscribe it. Thank you.